We're going to review today solving equations and inequalities, focusing on addition and subtraction. An equation is a mathematical statement that shows the equal value of two expressions, while an inequality is a mathematical statement that shows that an expression is lesser than or more than the other. An equation shows the equality of two variables, while an inequality shows the inequality of two variables. This Venn diagram shows a comparison of the two. Again, if you'll notice that there are a lot of similarities between an equation and inequalities. They both can be adding and subtracting. Negative numbers have no effect on the symbols. Goal is to isolate the variable. What we do to one side, we must do to the other, and can represent problem situations. The biggest difference between the two is going to be how we represent our solution. And remember, an equation only has one solution, and an equality can have many solutions. So how do you name an equation looking at a model? So remember that the long rectangular shapes represent our variable, my x values, and the smaller square shapes, which could be either negative or positive, will represent our constant. So if I was to name this equation, this would be 1x plus 2 positives is equal to 6. Here's another example. Keep in mind that your algebra tile models can be represented in multiple ways. You will always be able to identify your variables as well as your negatives and positives. So in this particular case, I'm looking at on the left side of my balance, I have 4 positives is equal to an x, and these are 3 negatives, so it would be x minus 3. Again, we could also write that as 4 equals x plus a negative 3. Keep in mind those two things mean the same thing, okay? Addition is the opposite of subtraction. They are inverse of each other, and both of these actually represent the same thing. Here's another example. So I have 1, 2, 3, 4, 5, 6, 7, negative 7 on my left side is equal to x plus 6. Okay, so now let's talk about solving equations and inequalities. Remember, the only difference between an equation and an inequality is how we represent our answer. With an equation, you will have one solution, and an inequality, you will have multiple solutions. So that's going to be the biggest difference as we walk through it. Another important term to remember as we walk through solving equations and inequalities is the term zero pairs. In order for us to solve for that variable, we are going to have to isolate the variable. And isolating the variable means we have to create zero pairs. Remember, zero pairs have no value, but it's when you add a positive with a negative, then it equals 0. So if I have 2 positives and 2 negatives, the value will still be 0. So here are the notes that you should have. If you don't have a copy, remember you can go into Canvas, go to Module 5, and you will find another copy of the completed notes on there as well. But keep in mind whether we're looking at adding or subtracting equations, adding or subtracting inequalities, the process is going to stay the same. We are going to add the opposite to isolate the variable. The variable could be on the left side of the equation. It could be on the right side of the equation. It does not matter. The goal is to isolate the variable in order to see what the value of that variable will be. Okay, so that means I might need to add more negatives. Sometimes it also means that I'm going to have to add more positives. Either way, by doing so, we're going to make zero pairs with that number that's on the same side as the variable, which is going to then allow us to calculate the value for that variable. And it will be the same whether we're looking at inequalities or if we're looking at equations. So here I'm going to just walk through a few problems with you just to kind of give you a quick review of what it looks like. So the first one is just pretty basic. D minus 10 equals 8. So again, if I locate my variable here, I notice that the number negative 10 is what's on the same side as my variable. So to zero pair that out, I'm going to add 10 positives. If I add 10 positives to one side, I have to do it to the other. That's going to zero pair out those negative 10 that is on the same side as my variable, leaving me my variable by itself. And then on this side, I had 8 positives and I'm adding 10 more positives. So my answer would be 18. D is equal to 18. In this next example, pretty similar to the first, but I have an X and I'm taking away 18, or X, and I have 18 negatives there. It's equal to -2. Again, I want to isolate my variable. Since I have -18 there, I'm going to add 18 positives. If I do it to one side, I have to do it to the other. Bringing down my X, I've zero paired those 18s out. But on this side, now I had -2 already there, and I'm adding some positives. So this is what we have to also remember, our integer operations, that when we combine integers that are with different signs, that means we actually have to subtract. So in this case, I will be left with a +16. Last example, again, keep in mind the variable could be on the left side or the right side of the equation or inequality, and we're not going to try to move it. We're going to leave it there and solve it from there. Again, find your variable. I have +11 over there, so I need to add 11 negatives. Now, again, I write mine this way just because it's just easier for me to see that I'm adding the negatives. You can also write it if you're comfortable with it and you won't feel like you'll get confused. You can just say subtract 11. Okay, either way is going to get you the same thing. I always put add, so when I'm working my integer operations, I won't make that mistake there. So again, they zero pair out. My M is now isolated. I had -5, and I'm adding -11 to it. So that's going to make me, I'm not going to make any zero pairs. So that's going to leave me with a -16. Here's one that I want you to try. Okay, I'm going to just walk through very quickly. Isolate my variable by adding the opposite to both sides of my equation. -19, and I added +6. That is going to leave me with a -13 on this side of my equation. Bring down my variable, that zero pairs out. So B is equal to -13. Here's another one to try. Again, isolate my variable. There's -16 there, so I'm going to add 16 positives to both sides. Okay, that's going to give me an N. Zero pair that out, and that's going to leave me with a +8. Here's another example to try. Again, they can move the variables and the constants anywhere in the problem, but again, the goal is to isolate the variable. So this is actually +6, so that means I need to add -6 to both sides. So that's going to zero pair out on this side, leaving me a Y. I had -8, and I'm going to add -6, so that leaves me with -14. And guys, remember, as I said, you can just, as you get more and more comfortable and understand it, you can easily kind of drop some of those steps off. Instead of putting that plus a negative, you can just put the negative sign. But right now, as we're still trying to work on our integer operations rules as well, I would not recommend taking out those steps just yet. Go ahead and give this one a try. Okay, Z is equal to 16. The process does not change even when we start getting into decimals and fractions. Again, the goal is to isolate the variable. So since I have a +3.5 with my variable, I'm going to add -3.5 to both sides. You do have to keep in mind that with fractions and decimals, you have to line up the decimal point. So there's my N, zero pair, and then if I line up my decimal point, I have some positives, and then I add some negatives. So I'm going to actually subtract in this problem, and it leaves me with 3.2 or 3 2/10. Lastly, solving inequalities. Remember, it is treated the same way as solving an equation. It does not change. The goal is to isolate the variable. The only difference will be in how you represent your answer. So again, if you see here, my answer for this first example was X is greater than -8. So when I graphed it, I made an open circle and I shaded all the numbers that are to the right of -8, because all those numbers are greater than -8. In the sample over here, again, M is greater than or equal to 2. There's going to be a closed circle. And again, I shaded all the numbers leading to the right. And I continue with an arrow because the numbers keep going and going and going and going.